Hello guys, today we're going to be solving search in a rotated array. So basically, we're given a rotated array and what we have to do is just find the target number. So the target number will be given to us as target and yeah, the array is rotated. So let's go ahead and try to write an algorithm for this. We say left pointer will be equal to 0, right pointer will be equal to the length of the whole entire array, which would just be length of nums, but minus one just because Python is zero indexed. Now we go ahead and do two things. Let's go ahead and do while left pointer is less than or equal to the right pointer. We go ahead and run a condition. But first, let's go ahead and look at something like this. Let's go look at an example case and see what algorithm would work. Okay, so looking at this, we could see that left pointer will be at 3, right pointer will be at 2. Let's go ahead and do that. Left pointer will be at 0, right. Where's equal at? So 1, 2, 3, 4, 5, 6. 6 minus 1 would be 5. So we add them together and we get this position. We'll have a middle pointer equal 2, which is 6. This is equal to number 3. This will be equal to number 2. And this will be equal to number 6. So what kind of comparisons can we do with this? We know we should compare 6 with something. First, we could see if left pointer is greater than right pointer, then we do know and we can confirm that the array is rotated. So we want to go to a smaller number. We could compare it with our target. In this example, our target will be with a 4. So we're trying to look for the number 4 in this. We know 4 is not in there, so we could compare 6 with 4. I would say because we know that our target is smaller than middle, we should search the part of the array which is which is larger. So over here would land at 2. Okay. Over here, I would say middle. I want to bring this up. Middle's going to be equal to left pointer plus right pointer. Then we go ahead and divide this by 2. And now we go search our actually nums. So we do nums of middle and we compare it with target. First, we gotta check if it's equal to target. Nums is equal to target. Then we go ahead and just return just middle because we know that that's gonna be the correct index. Otherwise, we could do if nums middle is actually less than target. We want to actually compare left pointer and right pointer, see which one's larger. Mm. Um, Shit's doing too much. Okay. If the middle number is smaller than target, then we go ahead. See, shit, I think it's easier to see if target. Shit, let's do this. Okay, if this middle number is smaller than the target, then we should look at somewhere with bigger. Okay. We need to increase. How do we increase? We could increase this by actually moving to the left. Okay. All right, then we go ahead and increase it to the middle. We want right pointer equal to middle. Minus equals 1, or just -1. But if nums of left pointer is, let's say, smaller than nums of right pointer, then in this scenario, we actually in this scenario, let's see, left pointer is actually smaller. Okay, in this scenario, it's greater, but it's not. Okay, it's actually the reverse. We would say, how do we increase? Left pointer is smaller. Oh wait, right pointer. Hmm. Want that right pointer to go down. If left pointer is, and if this left pointer right here, 3 is less than right pointer, then left pointer is equal to middle pointer plus 1. Now we gotta do the reverse. Say this is greater than target. Then we actually want to do, go ahead and check these same conditions. Ooh, we gotta swap them a little bit. Okay, so if middle is greater than target, that means we have to actually decrease the number. So if num's left pointer, nub's left pointer is greater than this, to decrease it, we would have to bring this pointer up. So that would be left pointer is equal to middle plus 1. All right, so we need to go ahead and just reverse these. And after running all of this, we should either return middle, or if they didn't run, then we just return -1, saying that nothing ran and it wasn't fine. I think looking over all of this, it should be correct. Let's go ahead and just test it out. And looks like I did not define middle pointer. Um, yes, okay. And looks like middle pointer was supposed to be right here. Okay. And this works, so let's go ahead and, oop, and we missed a test case. So 3 was here. Hmm. Okay. Go ahead and try to run through this. Okay, so we had we hit quad. Ah. Okay, so this is the case where it doesn't work. And our target is 3, so okay, so we start with 5. Um, compute it. It's not correct, so we go ahead and bring it down. So we got 3 and 5. Um, okay, so using our algorithm, left pointer and right pointer, left pointer is less than right pointer. Middle pointer would be equal to this number right here. Okay, but the number we're looking for is 3, and 3 is actually going to be 3 is actually smaller. Okay, let's see. 3 is actually smaller than 5, or 5 is actually smaller than 3, or 5 is greater than the target. So we're gonna go ahead and go. We want the right one to go left. So num's left pointer is greater than right. Okay, so we know this. So our left pointer is equal to middle pointer. Our left pointer. Hmm. Left pointer is greater than num's right pointer. It is. So left pointer is equal to middle pointer. What? Okay, it is greater than target. 5 is greater than 3. So if 3 is greater than 1, then our left pointer, which is 3, should just equal to middle pointer. Minus 1. No, that don't make sense. Mm, yeah. Okay. I gotta try to think of how to solve this. Maybe I'll just use this. Forgot about some edge case. We should compare the middle. Which half is sorted? Okay, the pointer is equal to this. Ah. Hmm. Okay. Alright. Oh, yeah, that path sorted. We go ahead and just move right pointer to middle. If num's at this left pointer, okay, is less than target. Okay, that makes sense. And it is less than none. So basically what that's saying is, let's go bring this back. Go bring back the question. The conditions it's actually putting is kind of like this. So we're at 5. So 5 isn't our target. Our target is actually 4. Okay. So we go ahead check the left. If this left side is greater, or if this left one 3 is smaller than 5, then we know it's sorted. So we go ahead and just run a binary search in it. We could do that by setting. Or we could do this by doing and now we could check if num's left pointer, if this 3 is less than or equal to the target. And then we say it's also less than or equal to two nums. And if it is, then we go ahead and move our pointer. See, target is not in this range, so we just check the other one, man. I would say left pointer is equal to sure +1. Yeah, and now we write the other condition. So this is actually greater than target. For example, if we see like a 6 right here, right? And then oh okay, let's go try to run that condition. Okay, let's say we're at 1, right? We're at 5. Our target is 4. 4 is smaller than 5. First, we check the left pointer. 3. Then we gotta actually check. Let's see, our target's 1. See, it's 6. Well, left pointer's gonna be 3. But a pointer's less than target. If it's greater. Check the other side, check the right. Check the right. Needs to check if it's sorted first. Wait, that logic's crazy. The freak. If num's of middle pointer is equal to target, then we know it's good. We hit the target. If num's left pointer is that, okay. Then we could say it's sorted. Say right pointers, self it. Is greater than target. I'm gonna say target between sorted right here. Mhm. Thank you. Yeah. Okay, thank you, man. Yeah, thanks. Less than target, yeah.